Alright, you're welcome again. So from the previous video, we talked about the properties we can obtain from the operation table, and today we will be looking at performing the operations itself, like giving this, showing how these properties are actually gotten from the table. So here from this question we have, it says show that z modulo 5 is performed on the operation plus is a group, and Z modulo 5 is actually trying to tell you that the properties of Z is from 0 to 4. So 0, 1, 2, 3, 4 must not be up to 5 and must not exceed 5. So we get to draw our operation table. So if you actually go back to the previous two videos, we talked about the operation table and now it has been done. So we have from 0 to 4 here, and from 0 to 4 here. So 0 plus 0, we have 0, 0 plus 1, and then we get all this. We have 3 plus 3, 6. 6 cannot be on the operation table, so we have 6. We have 6 divided by 5, which is equals to what? 1, remainder 1. That's the reasons why we have 1 here. And then also we have 4 plus 4 gives us 8. We have 8 divided by 5 is equals to 1, remainder 3. Reasons why we have 3 here. So now we are going to look at how these properties are observed on this table. The first is the closure property. The closure property, remember, it states that A plus B in Z5 and whatever we get will be in Z5. So let A be 1 and B equals to 2. 1 plus 2 equals to 3, and we have 3 in Z5. Let's check for 3. We have 3 here, we have 3, we have 3. So the closure property what exists. The next is the associativity property. The associativity property states that A plus B, open bracket, B plus C equals to, open bracket, A plus B, close bracket, plus C. So whatever we get, this will be equals to this, and it must be inside the table. So let's put A as 1, B as 2, and C as 3. So if we start from here, 1 plus 2 and 3 gives us 2 plus 3 from the table. If we check from the table, 2 plus 3 gives us 0. So we have to come here and write 0. Remember, 2 plus 3 naturally is 5. 5 divided by 5 is 1, remainder 0. That's the same reason why we have the same 0 here. 1 plus 2 is 3. Now we have 3 plus 3 and 1 plus 0. 1 plus 1 gives us 1. And 3 plus 3 gives us 1. How? Come on. 3 plus 3 equals to 6. And it must not exceed 5, remember? So 6 divided by 5 gives us what? 1, remainder 1. Reasons why we have 1. And we have 1 right here in the table. The next is the identity property. So now the identity property states that there exists a unique element E such that the element A performed on the binary operation by E will give us A. So let's see, A plus E equals to A. Let's give A as 1. So that means you are trying to say 1 plus E equals to 1. What do we add to 1 to give us 1? It should definitely be 0. And even from the table, if we come back, 1 plus 0 gives us 1. 2 plus 0 gives us 2. 3 plus 0 gives us 3. 4 plus 0 gives us 4. Therefore, that means the identity element for the binary operation plus in every table is 0. Because here we also tested that if A is 2, we still have a 0. Therefore, we have E equals to 0. And you need to note that the identity element for the addition sign on every table is 0. The next property we'll be looking at will be inverse. Remember from the last video, we made a statement that for a set to be called a group, it needs to have four properties. The closure property, the associativity property, the identity property, and the inverse property. Now the inverse is the last one to prove that this is a group. So let's have it done. So here is it. The inverse states that there exists a unique element E such that A multiplied by the A inverse equals to E. And recall that E equals to 0. So if A is equals to 1, we have 1 plus A inverse equals to 0. 1 plus 4 equals to 0. How? How can 1 plus 4 be equals to 0? Let's take a stroll back to the table. 1 plus 4 equals to 0. How is this done? 1 plus 4 equals to what? 5 naturally. And 5 cannot be on this table. So we get to divide 5 by 5 and give the modulo, which is equals to what? 1 remainder 0. Reasons why we have 0 here. So that's trying to tell you that the inverse of 1 is 4. Then we look at what? Now, a very simple trick. We get to look at where zeros are so we don't start to give ourselves stress. 2 plus 3, 0. So we pick this 0, we pick this 0, we pick this 0, and we pick this 0. So the inverse of 1 is what? 4. The inverse of 2 is what? 3. The inverse of 3 is what? 2. The inverse of 4 is what? 1. So wherever the 0 links them, do you get that? Just to save your time during your exams. You get that clear? So with all this property, and this is the solving method, how we got to write it down all through. So with all this property existing, the closure property, associativity property, identity, and inverse, then we can conclude that hence Z5 performed under the operation plus is a group. Thank you very much for subscribing to my channel and turning the notifications button on for more videos coming up.